Hi, November students studying HL. This is Ms. Palika. I wanted to teach decision trees, which is 10.03. So if you would like to keep 10.3 opened as I'm explaining this, this is your first a financial quantitative element, and then I thought perhaps you might help if I were to teach this. So what I'm going to do from now on is whatever quantitative topics are there, and if I feel that um, you might struggle in understanding it, I might actually put together a quick video like this of myself teaching. Okay, I do a few for the May session as well, so I thought why not for you. I've never done for decision trees though. So this is decision tree. So while you see this, I would like you to keep your 10.3 opened, please, on Canvas. It just helps. So that question is, there are three options that Goal PLC has. One is option one of buying new players. Option two is building, I think, a stadium, and option three is renovating it. Okay, so each have a cost to it, and there are three. With decision trees, it's a scientific tool because it hasn't happened. You're trying to forecast into the future, and you're looking at economic forecasts, what industry experts have to analyze and say. So you're basing your decision on some very solid evidence that you have in front of you. So over here, economists predict that, well, the chance of the economy improving in the future is only 20%. For the economy to remain unchanged, it's 50%. And for the economy to worsen, the probability or the chance of that happening is 30%. So when you are contemplating, especially for UHL students, because when you do your internal assessments next year, you would probably end up using decision trees yourself. So you'll be doing this estimate based on what you've read, what industry analysts have to say. So this is a very quantitative application of qualitative information. Okay. So the way it works is, you've got your decision node, and you've got three options, right? So there are three options here. One is option one, which is buying new players, option two, and option three. We'll write down the cost to that. I'm going to use a red pen to rate that it is a cost. So the cost for option one is $2 million. The cost for option two is $3 million, and for option three, it's $1 million. Okay. Now within each options, you have to draw this diagram yourself. So it really helps to know how to draw. Okay. So within each option, there are three things that could happen. Either the economy is going to improve, it's going to remain unchanged, or it's going to get worsen. It's going to worsen. Okay. So you've got three options there. I like to end my decision tree at one sort of an angle there, and not keep it haphazard, so it's very organized and neat. So you end this like that. Okay, so each represents improvement, unchanged, situation, worsen, improve, unchanged, worsen. I'm going to use say purple to reinforce the probabilities. So for it improving, the economy improving, it's 0.2, which is 20% chance. That's 0.5, and that's 0.3. So write this down for each. And now what we do is, we're trying to base our decision on some very solid financial data that we have. Okay, so we're going to do some maths here. So what you're going to find out here would be the expected monetary values, which we find out by, so against each, so this is what we've written so far. So what you expect to receive for each scenario has to be written as well. So if in option one, the economy improves, you're going to likely make $5 million. you're going to write that. If it remains unchanged, you're going to write you're going to make $4 million. And if the economy is going to worsen, well, you're going to make only $1 million. You see how you're justifying under different situations with different probabilities what you're going to receive, what you're going to expect to make. So I think it's a very, very scientific way of coming at or arriving at decisions. Okay. Likewise, for option 2, if the economy improves, you're going to make $6 million. If it is unchanged, to make $5 million. And if it worsens, for the first time, you're going to lose $1 million. You've got to write -1 there. Okay? And likewise, for option 3, I'm just going to get the option 3 a little bit down because it's just too much crammed there. So I'm going to push this down a little bit so we can see as well clearly. So if it improves, you're going to make $3 million. You're going to earn $2 million if it remains unchanged, and if it worsens, you're going to make only $1 million. So once you write this, the next is just a matter of the mathematical thing that you have to do. So we need to now decide which decision to go with. Is it decision 1, 2, or 3? So I'm going to just draw a line there so I can distinguish each, and I'm going to do the, so it's 5 million times 0.2, 4 million times 0.5, 1 million times 0.3. So we get, that's I think 1 million, 2, and that's 0.3. So add all these, it gives you 3.3 million, just to have it there. Likewise, you do 6 mil times 0.2, 5 million times 0.5, and -1 million times sometimes students forget to write the negative sign. You have to be very careful. So that's going to give me 1.2 mil, 2.5 mil, and -0.3 mil. So I'm going to add all of that. That's 3.7 minus 0.3 would be how much? 3.7 minus 0.3 would be 3.4. Okay. Next, 3 million times 0.2, 2 million times 0.5, and 1 million times 0.3. So that's 0.6 million, 1 million, and 0.3. So that's going to give me $1.9 million. So we've arrived at this stage. Now you need to do something with the costs that we wrote there, you see. So all we have to do is take out the costs, which is 2 mil there. So this gives you $1.3 million. Take out $3 million and you're left with $0.4 million, and take out $1 million, that is $0.9 million. So you see, you expect that if you were to renovate, you're going to spend $1 million, but if you bought new players, you're going to spend $2 million, and if you were to build the stadium, you're going to spend $3 million. So once you do this, you go with the one that is giving you the highest expected monetary values, and that's going to be, in this case, undoubtedly this one, you see, option 1. Now oftentimes students are in a rush. They don't show on the decision trees what their choice is. You have to highlight what your final choice is. So the way to do that is you put a arrow there and just place 2 crossed lines there, parallel lines on these 2, which means that you're leaving out option 2, option 3, and you're going with option 1. Okay, so I hope you understood decision trees. You could get more complicated ones, but this just gives you an idea of how to actually draw and how to do the maths, how to arrive at the correct answer there, which is the highest EMV that you obtain for each option. Okay, thanks for that.